Welcome back to Books in Focus podcast.
Today, we're tackling the fascinating art and science of speaking to AI, specifically large language models, or LLMs.
That's right.
Our guide for this deep dive is the incredibly insightful book, Prompt Engineering for LLMs, the art and science of building large language model-based applications. And what makes this source so powerful? Well, it's written by John Berryman and Albert Ziegler, two founding engineers on GitHub Copilot.
Yeah, the first big, successful industry LLM product. They were right there.
Exactly. They literally helped design the prompt engineering systems that made Copilot work.
Amazing experience to draw on.
Totally. So our mission today is all about prompt engineering, the critical skill for unlocking the true potential of these LLMs.
Absolutely essential.
Think of LLMs as incredibly powerful, yet sometimes delightfully naive friends who've somehow absorbed the entire internet.
A good way to put it.
This deep dive will teach you how to speak their language effectively, transforming your ideas into a format they can truly understand.
Let's get into it.
So, most of us have already experienced the sheer magic of LLMs firsthand, right? Maybe through tools like ChatGPT.
Oh, for sure.
Which, astonishingly reached 100 million users in just 2 months. That's wild.
Incredible growth.
LLMs can generate content, answer questions, summarize text, do almost anything you can do with text, but orders of magnitude faster and, well, tirelessly.
Yeah.
It certainly brings to mind Arthur C. Clarke's famous quote, "Any sufficiently advanced technology is indistinguishable from magic."
It absolutely does feel like that sometimes. But what's truly fascinating here is how our source material, this book, it really pulls back the curtain on that perceived magic.
Okay.
It reveals a core truth that's essential for prompt engineers. The big reveal is that no matter how uncanny or human-like LLMs seem, at their core, they're simply models that predict the next word in a block of text. That's it. Nothing more fundamental.
Just predicting the next word seems too simple for what they can do.
Well, that's the thing. The real insight for prompt engineers is understanding how this seemingly simple mechanism creates such complex, emergent behaviors that feel like intelligence.
Oh, okay.
Your entire interaction with them hinges on crafting this block of text, which we call the prompt.
Right.
Prompt engineering, then, is the art and science of perfecting that prompt, making what seems magical, well, understandable and controllable.
That's a crucial distinction, mimicry over genuine understanding. So to truly whisper to an LLM and get precisely what you want, you really need to understand how it thinks, or maybe more accurately, how it processes.
Exactly. How it's processed.
What are some of those core mechanics the book highlights?
Well, that leads us straight to the fundamental rules governing an LLM's behavior. At its most basic, it's just text in, text out.
Simple enough.
An LLM takes a string as input the prompt and returns the string as output the completion.
Okay.
And these models are trained on vast data sets, billions of documents, books, articles, conversations, you name it.
Huge amounts of data.
Immense. But their goal isn't really to memorize that data. It's to learn the patterns within it and apply those patterns to new prompts. In fact, mere rote memorization is actually considered a defect.
Right, you don't want it just spitting back training data verbatim.
Exactly. And critically, when you send text to an LLM, it's first broken down into tokens.
Tokens.
These are multi-letter chunks, typically 3 to 4 characters long. LLMs don't see individual letters like we do.
Ah, that's interesting.
Yeah, which is why tasks requiring precise letter-by-letter manipulation can sometimes be difficult for them.
Makes sense.
And a subtle but really important detail here is how capitalization significantly changes tokens. So for instance, Apple, the company, and Apple, the fruit, might be processed as entirely different tokens by the LLM.
Wow. So if you prompt with Apple in all caps and then later Apple in lowercase, the LLM might process those as two distinct chunks of information, even though they look similar to our eyes.
Precisely.
That subtle difference could really impact how it responds.
It absolutely can. And adding to that, LLMs generate responses sequentially, one token at a time.
One by one.
Yeah. They don't pause to think or go back and edit previous tokens, which is a key difference from how we humans process information. This means their thinking has to happen out loud, so to speak, in the generated text itself, which is something we can actually leverage, as we'll see.
Okay, interesting.
One more critical point.
Yeah.
Because LLMs aim to produce plausible-looking text based on patterns, they can sometimes generate hallucinations.
Ah, yes, hallucinations. Heard about those.
Right. Factually wrong, but confidently presented information. The book highlights a crucial, almost insidious aspect. LLMs operate with a truth bias. They tend to assume your prompt is factual.
That truth bias is fascinating and frankly a bit unsettling. Does this mean if I accidentally feed it a faulty premise, it'll just confidently build an elaborate castle of lies on top of it?
Exactly. That's a great way to put it. The book emphasizes that the best antidote for you, the prompt engineer, is trust but verify.
Always verify.
If you feed it garbage, it will confidently build on it. So you're responsible for the quality of the input.
Got it.
And finally, there's temperature. This is a crucial parameter that controls how creative or stochastic the model's completion is.
Temperature. Right.
A temperature of 0 means the most likely token is always chosen. This leads to more predictable, but sometimes repetitive output.
Okay.
Higher temperatures introduce more randomness and creativity, making it feel more imaginative, maybe more human-like sometimes.
So we've peeled back the curtain a bit on how LLMs fundamentally operate simple mechanisms creating these complex outcomes. But these models didn't just appear fully formed, did they?
Oh, definitely not.
Their evolution has been incredibly rapid, transforming them from simple text completers into really versatile tools. Let's look at that journey.
That's right. And if we connect this to the bigger picture, this evolution is really about making LLMs not just intelligent seeming, but also useful and safe for a wide range of applications.
Useful and safe. Key points.
Absolutely. Initially, we had base models. These just mimicked documents they were trained on, which often led to, well, undesirable or unhelpful responses.
Right. Could go anywhere.
Yeah. So, to make them more useful, instruct models were trained specifically to follow user instructions.
That's better.
Much better. Then came chat models, like ChatGPT, which are fine-tuned specifically to engage in conversations.
Like we're used to now.
Exactly. And things like OpenAI's ChatML markup became critical here.
ChatML. What's that?
It's basically a way to structure the prompt to give the LLM clear signposts. It prevents it from confusing who's saying what. In a complex conversation, the user, the assistant, previous turns.
Yeah, okay.
Think of it like explicit stage directions for the LLM, ensuring it understands conversational turns, user instructions, and its own previous responses.
That's a great analogy, making sure the play runs smoothly. What else has contributed to these models becoming so much more capable and, frankly, better behaved?
A huge leap came with reinforcement learning from human feedback, or RLHF.
RLHF, heard that term a lot.
Yes, it's often described as the secret sauce behind well-behaved LLMs. RLHF fine-tunes models to be helpful, honest, and harmless, the HHH principles.
Helpful, honest, harmless.
Exactly. It's about shaping their behavior to be reliable, safe, and aligned with human values, which is obviously crucial for real-world deployment.
How does it work, basically?
Well, it involves humans ranking different model responses, essentially teaching the LLM what good quality looks like from a human perspective.
Humans guiding the AI.
Precisely. However, this process can sometimes lead to what's called an alignment tax.
Alignment tax.
Yeah, it means that in making the model safer and more agreeable generally, it might potentially become slightly dumber or less capable at certain specific, perhaps more niche tasks. It's a trade-off.
Interesting trade-off. Safety versus raw capability sometimes.
Sometimes, yeah. And then there's tool usage. This is a massive game changer.
Tool.
LLMs, by themselves, are kind of isolated, right? They're stuck with the knowledge they were trained on. They can't access real-time information, perform complex math accurately, or interact with the outside world.
Right. They don't know today's weather.
Exactly. Tool usage allows LLMs to reach out into the real world by calling external APIs.
APIs, okay.
So they can do things like check the current weather, book flights, search a database, send emails, you name it. The LLM proposes a tool call, your application executes it, gets the result, and feeds that result back into the prompt for the LLM to continue reasoning with the new info.
Wow. So LLMs are no longer these isolated geniuses. They've become capable team players, able to pull in information from pretty much anywhere.
That's a great way to think about it.
The book frames prompt engineering as playwriting, which I really like as a metaphor.
Me too.
You, the prompt engineer, are the lead playwright, crafting a script, the prompt that involves characters like the system, the user, the assistant, maybe tools, and their dialogue works together to solve a user's problem. Okay, let's unpack this playwright's toolkit. What are the key techniques?
Understanding these core techniques is absolutely essential for truly mastering communication with LLMs. At its heart, an LLM application, the thing you build, acts as a transformation layer.
Transformation layer.
Yeah, it bridges the gap between the user's complex problem, say planning a really detailed travel itinerary, and the LLM's simple core task, which is just completing text.
Okay.
Your app converts the complex problem into a suitable prompt, gets the completion back from the LLM, and then transforms that back into a meaningful solution for the user.
Got it. Translating back and forth.
Exactly. And a core takeaway, which the authors brilliantly call the Little Red Riding Hood principle, is this. Don't stray far from the path upon which the model was trained.
Huh. Don't go off the path. Love it. What does that mean practically?
It means making your prompts resemble the kind of documents and patterns the LLM saw during its training.
Ah, okay.
So things like using markdown formatting or structuring your request like a specific report format it might have seen. This helps ensure more predictable and stable completions because it feels familiar to the model.
That makes so much sense. Give it something familiar to work with, like speaking its native language.
Precisely.
Yeah.
Now, what about the actual content we put into these prompts?
Yeah, the words themselves.
That's where static content comes in first. This is the unchanging boilerplate part of your prompt.
Boilerplate, okay.
It defines the general task, clarifies your core question, and sets precise instructions that don't change from one request to the next.
Right. The standard stuff.
Exactly. Yeah. And a really powerful form of static content is few-shot prompting.
Few-shot. Heard of that.
This is where you provide the LLM with several examples of the desired input-output pairs directly in the prompt.
Giving it examples.
Yes. LLMs are excellent at picking up patterns, so this implicitly teaches them the exact format, the style, even the persona you expect in the response.
Very clever. Any downsides?
Oh, definitely. Few-shot examples can take up a lot of valuable context space, so it scales poorly with really long context. They can also bias the model heavily towards those specific examples.
Right.
And you might accidentally introduce spurious or unintended patterns if your examples aren't carefully chosen.
Okay, so powerful but needs care. Static content sets the stage. What about the ever-changing bits that make each interaction unique, like the specific user's question?
That's dynamic content. This is the information that changes with each user or specific problem instance. It provides the necessary context and details.
Like
User-specific preferences for that travel itinerary, or maybe recent news headlines, or the content of a particular document you want summarized.
Gotcha. The specific details for this request.
Exactly. And speaking of dynamic content, retrieval augmented generation, or RAD, is a crucial technique here.
RAD, another big one.
Huge. Your application first retrieves relevant external content, maybe from your company's internal knowledge base, recent news articles online, or even your personal notes, and then incorporates that retrieved information directly into the prompt before sending it to the LLM.
So you're giving the LLM fresh, relevant info right when it needs it.
Precisely. This helps LLMs access information far beyond their original training data, and it significantly reduces the chance of hallucinations because it has the facts right there.
Makes sense. Facts in, facts out, hopefully.
Hopefully. The book discusses both basic lexical retrieval, which is essentially just keyword matching.
Simple search.
Yeah. And also neural retrieval. Neural retrieval is far more sophisticated.
How so?
It uses embeddings, which are basically numerical fingerprints of words or sentences that capture their meaning, their semantic content.
Meaning not just words.
Exactly. This allows the system to find not just documents with the same keywords, but documents containing semantically similar information, even if the exact words aren't present. It's a huge leap in understanding the context needed.
Neural retrieval sounds like it goes way beyond just keywords to truly grasp the meaning of what you're looking for. That's powerful stuff.
It really is.
Okay, so once we have all this content, static, dynamic, maybe retrieved stuff, how do we assemble the prompt to make sure the LLM actually uses it effectively? Does the order matter?
Great question. Yes, order and structure definitely matter. You need to organize your content strategically. The book highlights something called the Valley of Meh.
The Valley of Meh sounds ominous.
Oh, yeah. It refers to the observation that information placed in the early middle of a very long prompt is often less effectively used by the LLM.
Like its attention wanders.
Kind of like that. It's like a human's attention span fading a bit in the middle of a lengthy monologue. The stuff at the beginning and end gets weighted more heavily.
Okay, so how do we fight the Valley of Meh?
The sandwich technique is incredibly effective.
Sandwich technique.
You state your main question or your most critical instruction at both the beginning and the very end of the prompt.
Ah, bookending it.
Exactly. It refocuses the model's attention on the key task. And crucially, ensure there's a recognizable start and end marker for your expected completion. Something predictable like completion or specific XML tags.
Why is that important?
It allows your application to easily parse the LLM's output, extract the bit you actually need, and know when to stop the generation process cleanly. Avoids run-on responses.
That's a clever, practical tip. Keep the LLM focused and make the output easy to handle. Now, moving beyond single, meticulously crafted prompts, our source material delves into how to build more sophisticated LLM applications.
Yeah, this is where it gets really interesting.
This is where you really start to see the potential for solving truly complex, multi-step problems.
Absolutely. This leads us to how we empower LLMs to handle these multi-step, nuanced tasks more autonomously. One key concept the book discusses is conversational agency.
Conversational agency, what's that?
It's about giving the LLM the ability to complete tasks and achieve goals in a more self-directed manner, primarily through dialogue.
So it takes initiative.
Kind of. It combines the chat model capabilities with tool usage and, importantly, enhanced reasoning abilities.
Okay, reasoning. How do you enhance that? They don't really reason like us, right?
Right. Since LLMs lack a true internal monologue or scratch pad like we have, we use specific reasoning techniques within the prompt itself.
Like chain of thought.
Exactly. Chain of thought prompting, where you explicitly ask the model to think step by step or show your work, is a prime example.
Makes it write out its reasoning process.
Yes. Or techniques like React, which is even more structured. It interleaves thought, action, like calling a tool, and observation, the result of the action step.
Thought, action, observation. Okay.
These techniques make the model much more accurate, especially for complex problems, because it forces it to articulate its reasoning process externally in the text. And it makes it easier to debug when things go wrong.
I can see that. You see where it went off track.
Precisely. And then there's reflection, which takes this even further, allowing the model to actually review its own work, identify potential mistakes, and learn from them for the next attempt. Self-correction, essentially.
Wow, self-correction. That's getting quite advanced. So we're basically teaching them to show their work, which I imagine makes debugging a lot easier.
Much easier.
But for really large, complex problems, maybe something that requires multiple steps, different kinds of analysis, how do we break those down? Is it still just one giant prompt?
That's where LLM workflows come in. For complex, multi-step problems, it's often much better to break down the large task into smaller, well-defined subtasks.
Makes sense. Modular approach.
Exactly. Each individual subtask might use an LLM, perhaps configured differently, but then you have a supervisor, which could even be another LLM, coordinating these tasks.
An LLM managing other LLM?
Yeah, it's becoming more common. Workflows can be simple pipelines where tasks just happen sequentially, one after the other, or they can be more complex, directed as cyclic graphs or DAGEs. That allows for branching logic. If this happens, do task A, otherwise do task B.
More sophisticated flow control.
Right. The book even touches on cyclic graphs, where information can actually loop back for correction or refinement. Think of that reflection idea, but applied across a workflow.
Looping back. Interesting.
This modular approach makes building and, crucially, debugging these really complex LLM applications much, much easier than trying to manage everything in one monolithic prompt.
This all sounds incredibly powerful, building these complex agents and workflows. But the million-dollar question for any engineer or anyone building a product is always, how do you know if your LLM application is actually working as intended?
Evaluation, yes. Critically important.
The authors, drawing on their GitHub Copilot experience, really emphasize that evaluation is absolutely critical, not just for launch, but for guiding future development. So what does this all mean for building truly reliable LLM tools?
This highlights a crucial aspect of developing effective LLM solutions. You absolutely need rigorous testing. You can't just ship it and hope.
Right.
First, you have offline evaluation. This happens in the lab, basically, before any real users see your app.
In the lab, okay.
You use a test harness automated testing infrastructure with a set of example inputs, your test cases, to see if the LLM's output consistently meets your expectations.
What kind of expectation?
Well, methods include gold standard matching, where you have a predefined correct answer for each test case, and you just compare the LLM's output to it.
Simple comparison.
Yep. Then there's functional testing, which is more about checking if the output actually works.
Yeah.
For example, if you're generating code, does it compile? Does it pass unit tests?
Does it do the thing it's supposed to do?
Exactly. And surprisingly, you can even use an LLM itself as a judge to evaluate the quality of another LLM's output.
Whoa, an LLM judging an LLM. It's quite a meta development. How do you make sure that LLM judge is objective and not just, making things up or being biased?
Yeah, that's a great point. To make an LLM a good, reliable judge, The book suggests using a SOMA assessment framework.
So,
Stands for specific questions ask very concrete things like, is the generated summary factually consistent with the source text?
huh.
Ordinal scaled answers use a rating scale, like 1 to 5, not just yes, no. And multi-aspect coverage evaluate different qualities like correctness, style, conciseness, safety, and so on.
Specific, ordinal, multi-aspect, SOMA.
Okay. This structured approach helps make the LLM's judgment more objective and less prone to its own biases or whims.
That makes sense.
Hmm.
Structure forces objectivity. What about testing with real users?
Right, so that's online evaluation. This is about getting feedback from actual users in a live environment. The classic way is through A/B testing.
A/B testing, comparing versions.
Exactly. You roll out 2 versions of your feature, maybe one with a new prompt strategy to different user groups, and measure various metrics to see which one performs better.
What kind of metrics?
All sorts. Direct feedback. Simple thumbs up, down buttons are common. Functional correctness. Did the app actually do what it was supposed to do in the real world? User acceptance is a big one. Did users actually click on, use, or follow the suggestion? Like Copilot's acceptance rate is a key metric for them.
Did people actually use the suggestion? Yeah,
Important.
very. Also, achieved impact. Did using the feature actually benefit the user? Did it save them time? Did they complete their task faster? And then incidental metrics, things like latency. How fast was the response? Or maybe total conversation time?
It's clear that measuring impact both in the lab with offline tests and in the wild with online evaluation is absolutely key to refining these applications and making them truly useful.
Couldn't agree more. Iteration based on data.
Now, the pace of change in LLMs feels like it's accelerating every single day. It's hard to keep up. Our source material gives us a glimpse into some truly exciting upcoming developments. What's next on the horizon for LLMs and prompt engineering? Where are things headed? It's moving incredibly fast. What's truly fascinating here is how these trends point towards LLMs becoming even more deeply and seamlessly integrated into our digital lives, often in ways we're only starting to imagine.
Like what?
Well, expect multimodality to absolutely explode.
Multimodality meaning more than just text.
Exactly. LLMs will increasingly process images, video, maybe even audio, directly as part of the prompt.
Wow.
This will enable them to understand things like spatial reasoning from a diagram, social cues from a video, or just physical common sense about the world much better than text alone allows. Plus, it provides a vast new source of training data as models inevitably get larger.
Understanding pictures and videos, that opens up so many possibilities. What about how we interact with them?
Good question. In terms of user experience and user interface, the future of LLM interfaces looks like it's moving beyond simple chat boxes towards more conversational interactions with what the book calls stateful objects of discourse, or maybe more simply artifacts.
Artifacts sounds like something out of a sci-fi movie again. Can you explain that a bit more simply? What's an artifact?
Yeah, maybe the term is a bit much. But imagine this. Instead of the LLM generating a whole new isolated block of text or code every single time you ask for a modification.
Which is how it mostly works now.
Right. Instead, the LLM is actually collaborating with you on a living document or a piece of code or a presentation slide, something persistent that you can both see and directly modify.
Ah, so it's like we're working on the same thing together.
Exactly. These aren't just outputs anymore. They're persistent, evolving objects, these artifacts. It makes the interaction feel much more like a shared workspace or a true collaboration tool. So less like ask and receive and much more like co-create and refine.
That sounds like a much more natural and powerful way to work with AI co-creation.
It really does. And finally, just in terms of sheer intelligence, or perhaps predictive capability models, are just getting smarter, faster, and cheaper all the time.
Moore's Law for LLMs.
Kind of feels like it sometimes. Benchmarks are constantly evolving just to keep up with their rapidly increasing capabilities. And techniques like knowledge distillation.
Knowledge distillation.
Yeah, where you train smaller, more efficient models to mimic the output of larger, more powerful teacher models. And also quantization, which reduces the model size and computational needs without a huge hit to performance.
Making them smaller and faster.
Exactly. These techniques are making powerful LLMs more efficient and accessible than ever before, running on smaller hardware, even potentially on device.
So wrapping this all up, what does this deep dive mean for you, the listener, someone who's curious about or already working with LLMs? What are the core lessons?
I think the core lessons from this book and our discussion remain really clear. First, never forget that LLMs are fundamentally text completion engines that mimic patterns in their training data. They don't understand in the human sense.
Right. Mimicry, not magic.
Exactly. So as a prompt engineer, your job is really to empathize with the LLM, understand its limitations, how it processes information based on tokens and patterns. It's about being its best interpreter, guiding it effectively.
Guiding the mimic.
Precisely. And this understanding leads directly to those critical principles for effective prompt engineering that the book powerfully conveys.
Okay, let's recap those.
1. Don't distract them with useless information. Every token in the prompt potentially matters and costs money or time. Be concise.
Keep it relevant.
2. Make prompts decipherable to a human. If you can't easily understand what the prompt is asking, the LLM probably can't either. Clarity for us often means clarity for the model.
Good rule of thumb.
3. Lead them explicitly. Use clear instructions, maybe use examples like in few shot prompting. Don't assume they'll just infer your complex intent.
Direct.
Don't be vague. 4. Remember, LLMs aren't psychic. If it needs specific information to answer your question, you have to provide that information in the prompt or give it a tool to retrieve it using RAG or tool use.
Give it the context it needs.
Exactly. And finally, number 5, allow them, or rather encourage them, to think out loud, using techniques like chain of thought for complex problems. That externalized reasoning leads to better, more reliable, and more understandable solutions.
Show your work. It helps everyone.
It really does.
The world of LLMs is incredibly dynamic, isn't it? It's full of possibilities, moving way beyond simple chatbots now to truly collaborative intelligence, sophisticated workflows, maybe even co-creation on these artifacts.
The potential is just enormous.
This deep dive, drawing heavily on the insights from Berryman and Ziegler's work, hopefully provides you with the knowledge and maybe the confidence to approach, experiment with, and perhaps even build the next generation of LLM-powered applications.
Yeah, hopefully it demystifies it a bit.
We really hope you'll continue to explore this fascinating field. There's so much happening, and its incredible potential is really just starting to unfold.
Thanks for listening to Books in Focus. If you enjoyed this episode, follow the podcast and share it with someone who loves learning. Catch you next time and keep your mind in focus.